1-7, and 1-7 is solutions of equations versus roots of functions. So our essential question today is, how are solutions and roots related? And the lesson target will be to understand the relationship between solutions, roots, zeros, and x-intercepts. Okay? So, equations and functions. So, a solution is a number that makes an equation true. The set of values in a system that makes all equations true. A root is a value that makes a given function equal to 0. And a 0 is any value of x for which the function f of x is equal to 0. And then we have an x-intercept, which is where a function's graph crosses the x-axis, and this corresponds to the solution of the equation when y equals 0, also known as f of x equals 0, because y and f of x are the same thing, also known as the root of the function or the zero of a function. So you're going to see these words used interchangeably, but they do have slightly different meanings in some contexts, so we'll talk about some examples of that. So, determine the solution when y equals 0, root 0, and x-intercept of the following. So, when they want you to determine the solution, like a root or a 0, what you're going to do is you're going to replace your y with 0, okay? So in our first example, we're going to replace our y with 0. And once we do that, we're then going to solve for x. Okay, we're then going to solve for x. So I'm going to add 4 to both sides. That's going to give me 4 is equal to 2x. Divide both sides by 2. And I get x is equal to 2. So this is what we would call a root or a 0. But if they want us to write our answer as an x-intercept, we would write our x-intercept as 2, 0, because that's where it would fall on the coordinate plane. So these are both versions of the answer, okay? So just be aware that if they want x-intercept, they want a number, 0, okay? Are there any questions about this so far? And everybody on virtual, you can see my screen now, right? I think I fixed it. All right, so we're going to try the same thing here. Okay, we're going to try the same thing here. The x-intercept of the following, well, we basically did the same exact thing. We would set this equal to 0, and we would solve, and we would get x equals 2 again. Okay, and here we would also get x equals 2. So the idea here is that you're looking for a root, you're looking for a 0, and then an x-intercept. We're going to write it in this form. So root x is equal to 2, 0, x is equal to 2, and as a x-intercept, it's 2, 0. And lastly, we're going to need to graph this to see where it intersects the x-axis. So we know that there's a point that exists 2, 0, right? And that would be our x-intercept. So I just plotted that point. So this is really just showing you there's 3 different ways that this can be asked, but the answer is going to be the same anyhow. Do you have any questions about this so far? Okay, and then just a reminder, what would I do if I wanted to find the y-intercept? I would plug in 0 for what? X. Good, thank you. Okay. Now moving on. Function key concept. Solutions, roots, zeros, and x-intercepts are different ways to write the same thing. This is one of the most important concepts to understand of this course. Okay? So you're going to see these words used interchangeably. The only exception to difference is x-intercept. You're typically going to see that written as an ordered pair. So the way they may be presented may be different, but essentially they mean the same thing. So let's go ahead and try this question. It says, given 3x minus y is equal to negative 15, find the x-intercept algebraically. So when I want to find the x-intercept, I plug in 0 for what? Very good. I plug in 0 for y. And when I subtract 0 from something, it doesn't change it, so I just am left with 3x is equal to negative 15. And then I'm going to divide both sides by 3. And that's going to give me x is equal to negative 5. So my x-intercept is going to be negative 5, comma 0. Okay? Any questions on that one? How we did it? Okay. So now we're going to state a root, or the root of, there's only going to be one, f of x is equal to 3x plus 15. So when you want to find a root of something, you're going to replace f of x or y, whichever one you have, with 0. Okay? So we're going to replace f of x with 0. And we're then going to solve for x. And that leaves me with x is equal to negative 5. So our root here would be x equals negative 5. Can also be written in the form of an ordered pair, but you'll often see it like this. So now we're going to look at the absolute value function. F of x is equal to the absolute value of x plus 2 minus 3, and its graph below. And we want to name all of the roots to the function. Okay? So do we need to do this algebraically with the information provided? No, we don't have to, right? What can we look at on the graph to determine the roots? Good, the x-intercepts, right? The x-intercepts. So this would be x is equal to negative 5, and you can also write this as negative 5 comma 0, and x is equal to 1, also known as 1 comma 0. Now, if you remember back to 1, 3, which we did last week, how you would go about solving this algebraically is you would set this equal to 0, like we do when we're trying to find a root, and then we would solve to get the absolute value alone on one side of the equation. And then what do we have to do with absolute value equations again? Good, we have to do a positive and a negative version. And then we would solve here, and I get x equals 1. And then over here, I'm going to divide both sides by negative 1. And I get x equals negative 5. So do these answers look correct based on the graph? Good. So I just wanted to show you that to understand that you can find and check your answers algebraically when you're given a graph. So if it's a high-stakes test, it's not a bad idea if you have extra time to go back and check your work algebraically to confirm you've done something correctly, or to use the graph to confirm your work when you do it algebraically. So it's a good idea to check your work whenever you can, whenever you have the opportunity. Do you have any questions on this before I move on? Okay. So lastly, we're going to look at the cubic function. F of x is equal to x cubed minus 2x squared minus x plus 2 is graph below. Name all the zeros of the function. So what do you guys think? What's my first 0? Good, negative 1. What else? And 2. And they can also be written in the form of an ordered pair, depending on what they're asking for. So most likely you do not know how to factor and solve this cubic function. We will learn eventually, but at this stage in the class, you haven't really learned this yet. But there is a way to check your work here. Now remember, zeros of the function are where the y value is 0. So you would replace f of x with 0. And what could you do to check and see if each of these x values is actually a root? Yeah, you could plug these x values in and make sure that both sides of the equation equal each other to make a true statement. So for example, I could do negative 1 to the third power minus 2 times negative 1 to the second power minus negative 1 plus 2. Negative 1 to the third power is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. Subtracting a negative 1 is addition. And I bring down the 2. Now these 2's cancel, and the 1's cancel, leaving me with 0 equals 0. So see how I was able to confirm my answer by plugging it back into the algebraic equation. So I highly recommend doing this when you're checking your work, especially when you're checking a graph. Okay? So I just want to show you how that all works out. Now there is a way to factor this. You would split it down the middle and you'd factor out an x over here, but you haven't really learned that yet, like I said. So let's just keep it to checking your work. So do we have any questions on this lesson at all? Okay. All right. You guys have the rest of the period to get work done. You can work on the 1-6 or the 1-7, and if you haven't done 1-5 yet, good time to do that because it's due very shortly.